Hi, I'm Edwin, and today we're going to talk about creative coding, live coding, and about OpenRNDR. I'm a creative coder. I'm also a partner of a studio called RNDR. It's a studio for interactive design based in the Netherlands. What we do is we make software-based design. So let's try to put that a bit into context with some videos. So what we see here is one of the very first things I made on my job as creative coder. I built a setup with a Kinect sensor and an iMac that plays the video of the powers of 10. And with the Kinect sensor, I essentially moved the playhead of the video further in time. So my position in space is somehow translated to the scales of the powers of 10, and it's a very nice experience. The sensor is really sensitive, so you can move just one centimeter on the tip of your toes, and you will move in those scales, and you can even move beyond the scales and go straight into the. So what we see here is a work called Uncode, and Uncode is a two-folded piece. On one hand, it is an autonomous art piece that shows live video footage to users, to visitors in a very interactive way. So they can navigate through space and time using a sensor that's installed in the space. And on the other hand, it's a work that tries to explain its own material. And we do this by visualizing the data that goes into the work, the sensor data, visualizations of the state of the piece itself. And yeah, we really try to explain to visitors how these kind of works are made. So what we see here is an installation called Reflector. Reflector was made in collaboration for the International Documentation Festival in Amsterdam. And what makes this installation interesting is that it offers visitors the opportunity to create their own edit for a documentary film. The edit is made in real time using machine learning technology applied to an archive that holds 60 hours of unedited footage. A visitor can set parameters that change the tone of the edit, so dark versus light, the types of shots used, so long or close up, and they can also determine the pace of the edit, so it should be a slow or a dynamic edit. The editing process is shown as a visual decision tree. So while the edit plays, it is still making decisions on which shots to play next in the sequence. And when you are in the space where this installation is, you can actually look at these sequences and see why the machine learning algorithm will pick the next sequence. And these last two pieces that I showed, they're all made with our own tooling. The reason why we made it with our own tooling was simply because the existing tools didn't really fit our way of working. And basically, alongside building such installations, we also build a framework of tools for making such installations. And yeah, pretty much out of that, the OpenRNDR framework was born. I don't have so much time to talk about what OpenRNDR really is. To sum it up quickly, it's a framework for creative coding written in Kotlin, and it mostly works on the Java virtual machine. And we're going to jump into how to use OpenRNDR right now. So let's get started setting up our very first OpenRNDR project. And we do this from inside IntelliJ IDEA. And the best way to start is by checking out our OpenRNDR template repository from GitHub. So we get this here, and we place this in the demo directory. And then we hit clone. And as soon as the clone is finished, we have a project here. There's a README. We don't need that now. And on the left side here, we see the programs that are in this template. So let's check out the template program. So we have our template program here. And let's first try to run this to see what it does. Okay, so this demonstrates how to draw an image, how to draw text, and how to do a simple animation. So I'm going to strip out everything that I don't need here, just to write my own small little program. So we see an application block, a program block, and an extend block. The program block is all the code that's executed once a graphical environment has been set up, and it's only executed once. Everything that's inside this extend block is executed every time we draw on the screen. So we can start writing a very simple program, and all it does is set the background to pink. All right, we run it. Okay, so that's a pink background. Then we want to set the fill color. So everything that's related to drawing, for that we use the drawer object. So we can set the fill color on the drawer object. I can set it, for example, to white. And that means that everything we draw after it will be filled with the white color. Then we draw a circle, and we center it in the screen, and we give it a radius of 200. Instead of using these fixed coordinates, we can also use the mouse coordinates. So I use mouse.position here to use the mouse coordinates. So when I run this program now, we have the circle centered on the mouse cursor. Okay. The OpenRNDR drawer, it offers functionality to not only draw circles, of course, but you can also draw rectangles, lines, shapes, images, and text. And I will demonstrate a bit of those, not in this, in the old-fashioned way, but I'm going to demonstrate those in the live environment. Okay, so let's have a look at the live environment here, and we see that it's almost exactly the same as a normal OpenRNDR program, except for one small detail, and that is instead of having a program block, we have an olive program block. And let me run this program. And I also set up some things in the configuration here to make sure that the window opens at a convenient place. So the window here automatically opens right next to my editor. Now I write an extend block here, and to demonstrate that the program actually updates automatically, I'm going to turn the background into pink again. So we see that it now automatically updates. I don't have to rerun the program. The program keeps running, and we can now basically iteratively write our program. So let's start with something here. I'm going to create something that is called a contour. A contour is basically like a path or a curve, a shape. So we start by moving the pen to 0, 0, so the top left corner, and we give another instruction as line 2. Okay, so we make this contour here C, and we still want to be able to actually see it, so we draw it using drawer.contour. Right, so the moment I save the file here, we see this line appear on our screen. Okay, now I want to make this a bit more interesting, so I add a curve to, which adds a Bezier curve to our contour. So the first argument here is like a position for a control point. Let's make this like 100, 50, and let's move this to 200, 200. So we have now this curved shape and a line segment attached to it. Instead of line 2, we can use smooth 2. No, sorry, that's called continue to make this shape less sharp, so nicely rounded. Then we can say continue to 300 and 100. No. Okay. Well, this isn't the best of shapes, but this will do for now. Yeah, we see that the moment we close this contour, OpenRNDR draws it in a filled fashion. Actually, I don't really want to see that now, so I turn off the fill. Okay. Next thing I want to do is to draw this shape multiple times. So I write a for loop from 0 to 10. And I use something that's called draw.isolated, and that allows me to translate the shape for every iteration in the for loop, independently of all the other things I do with the drawer. So I write here 0 y times 40, and that should be 0.0. Okay, so now we have repetitions of the same shape in one direction. And now I add the other direction as well. And I type x times 80 here. Okay, so now we have a grid of this shape repeating. And what I would like to do now is to use this grid sort of as a basis for animations. So there is this thing. When we have a contour, we can get something that's called a subcontour. So if I write sub 0, 0 to 0.1, we get like roughly 1/10 of the contour. Right, so I can make this longer and I can make this shorter. Okay, so let's introduce something that's called O for offset. And we say that this offset is now equal to seconds. And pass in O plus O. Right, so now we have a line animation. Let's make this a bit shorter. Going a bit too fast for me. Okay. Now all the copies are animating in exactly the same way. So let's try to spice it up a bit by introducing small variations. So in this calculation for the offset, let's try to include our for loop counters like this, and also add this one. So that's already an interesting sort of a line animation. Let's keep it at this. Okay, so we have seen that it's pretty easy to change the code of the program while it runs. We can change the animation, we can change the appearance of the animation. Basically, we can very easily iterate over our ideas while the program is running. I still think we can speed up this process just a bit more. And the way we're going to do that is by introducing a simple user interface that allows us to control many of the parameters of the program. So we start by adding something to the program that is called a GUI. So we make a GUI object, and then we install the GUI using extend. So the moment I'm saving this, we see this sidebar appear here. The sidebar is currently not populated, there's nothing in there, and that is because we haven't placed anything in there that is of use. So let's have a look here. We know that this 0.1, it controls the length of our lines, right? If I change this, they become shorter. Now I would like to control these from the user interface. So what I do is I replace this 0.01 with settings.length. Now this one will not compile because settings doesn't exist yet. So I'm going to make a settings object. And inside the settings object, I will add a length property. And I'm going to annotate this length property with the double parameter annotation. And the double parameter annotation is basically used to inform the user interface generator what kind of settings to use for our length. It now knows that the length is of a type double, but it also requires to have something like a minimum and a maximum value. Okay. Still, we don't see settings in the sidebar here, but as soon as I write add to settings, sorry, that should be add to GUI, we have it. So now it's called no name. Let's give this a name, settings. And we have this slider here. And when I change the slider here, we see that our animation changes because the line length varies. Okay. Let's make these lines just a bit nicer. So I set drawer.line_cap to round, and I set line join also to round. And this will be visible when we make the lines a bit thicker. So we set the stroke weight to settings.weight, and we add that here to the settings as well. We just copy this double parameter, call this weight, and that has to go from at least 1 to say 20. And yeah, now we have really nice looking thick lines. Okay, you can hide this to see it in full effect. Let's change some more things. We can change this spacing here. So let's call this x space and settings.y space. And let's make those from 40. Great. Also, let's change this speed here. Settings.speed. Okay, so the only thing left that we can change maybe is the color of the background and the colors of the lines. So let's set those two. So we set the stroke to settings.stroke, and we set the background to, sorry, we use settings.background here. So both of those things don't exist yet, so we add them. Far background, RGBA pink. That is called stroke. And those are annotated with something called color parameter. Okay, so we can change this one and this one. All right. A final thing I want to show here is that yeah, we have all these settings here, and we can actually save those settings. So let's call this one like session0100.json, and I can change all these settings here to make a new composition. And I can decide, well, the previous one was better, so I loaded the old one back in. So it's a really nice tooling for quickly trying out ideas for animations and compositions, quickly adding a user interface to it, and being able to save and load the settings that you have found while experimenting with those with those parameters. Okay, let's ramp up this live coding environment just one bit more. I'm going to use something that's called the Composer framework. And with the Composer framework, you can organize your documents into layered documents. On each layer, you can draw animations, and you can prescribe how these layers interact with each other through blend modes. And you can also add post-processing effects to each layer. So let's just show how that is done. So I start creating a composite using the compose function, and I am going to write in my extend block that we want to draw this composite. Then inside the composite, I create a layer, and inside this layer, I give instructions for what to draw on that layer. So let's run this program. Right, so it still doesn't do anything at this point. Let's draw one circle. Okay, let's say that radius for this circle is going to be based on simplex noise. And we do this like this. So instead of using a fixed radius of 200, I now use an animated radius. We can make this go a bit faster. Right, so it's now a noisy radius. I'm going to just do the same thing for the X and the Y position. So I copy this. And I use seeds 1 and 2 for X and Y. And I replace here for X and Y here. And we have to still center this properly. Okay, and let's make this move just a bit farther out. Okay, so we have one layer that now animates, and we can have two layers, but the two layers now use the exact same seeds, so we're not going to see any difference between them. So I change the seed values here. I'm doing this all wrong. This has to be in a separate layer. Okay, so now we have two layers with two circles under. Yeah, as I said, we can show how these two layers, how we can change the interaction between the two layers. Because as it is now, it's exactly the same thing as just drawing two circles after each other. So let's first introduce a background layer. And on this background layer, I'm going to use a filter that generates a checkerboard pattern. So now the background looks like a chessboard. And then we want to change the blend mode. But I think it's better to change the colors of the circles first. So the first one, first one we're gonna draw in red. And this, and the second one I'm going to draw in blue. Okay, now I changed the blend mode to multiply blend. And we see that now that the interaction between the two circles is that the color becomes black because the two colors are multiplied by each other. We also see that the blue circle applies, for the blue circle, also the multiply blend is applied with the chessboard. And actually we don't want this. We can fix this by wrapping all of this up into another layer. So we have, we have layer grouping here. Okay, now I want to show how to apply effects to the layers. So let's add a perturb effect here. This is one of the built-in effects. It's called perturb. And I would also like to change its settings. So we can actually inspect what settings this filter has here, but that is maybe a bit inconvenient. But we can introduce this GUI thing again. And we can add this thing to the GUI. And this is possible because the perturb effect has annotations built in. And this actually goes for almost all the filters that are inside OpenRNDR. So now we can just change settings of this filter here. For example, we can change some of its distortion settings, the amount of distortion, and the scale of it. Okay, let's do something about the colors. And this also shows that you can apply multiple filters onto a single layer, and also add this to the GUI. Color correction. So we can change the hue here. And let's also change the saturation a bit. Okay. Yeah, let's just add some more things. A Gaussian bloom, so that gives it a bit of a glow. Oh. See, now everything is nice and glowy. Now we can change this a bit. And let's add some. Now, before we do the Gaussian bloom, I would also like to add a bit of a drop shadow and add it to the GUI too. So we see there's like a faint outline now, and we can change that a bit. Okay, it's a bit too much. Okay, now that we have all of that, I would like to add a fluid distort as well. So now we see that there's like it's actually a fake fluid simulation, but it distorts the image nicely. Okay, let's try to change this into some sort of simple poster design, for example. I can do this by adding another layer with another draw on it. Inside this layer, I will load a font, data fonts, and there's something called default.ttf, and let's try size 128. And what we're going to do here is first tell the drawer to use the font, then let's say for I in 0 until 10 drawer.text OPENRNDR, and that will be at x coordinate 200, and add, I don't know, 100 plus I times 50 maybe. Oh, let's space it out just a bit more. Oh. Let's let's make this a bit more fun. Text, we can drop some characters from it. So let's set second based on the seconds, and a cosine pulsar times text dot length divided by 2 plus text dot length divided by 2. Yeah, so we have sort of this this typing effect now. It's just like the same for every time we write it, but if we add I here, yeah, we get this nice little walking text effect. Spice this up a bit with some drop shadows. Ooh. Okay, change the blur window on it. All right, I still don't really like the colors, but we can change this a bit here. This is not bad. Well, let's also try to distort the text. Yeah, well, so that shows how you can make really nice layered compositions, and all while the program is running. I think this is really, really nice. To wrap it up, and if you're interested in trying this out yourself, you can go to our website, openrndr.org, on which you will find many examples and videos and links to starting points. The most important starting point, however, is the guide, which you can find on guide.openrndr.org, on which we try to explain from like the very beginnings to the most complicated topics in a very, very visual way. And if you just want to very quickly jumpstart into OpenRNDR and the live coding examples I've just shown, I can highly recommend to start from the OpenRNDR template that you can find on GitHub. So all you have to do is, how I've shown you before, check this out in IntelliJ IDEA, and you can immediately run the template program, and you're all set. Great, and thanks for having me.